Physical properties. Ethers are going to be similar with their physical properties to alkanes. And they're going to have lower boiling points than comparable alcohols. So if we look here, it's always helpful to compare actual molecules. So here we have an alkane, and whenever we compare these, we need to keep the molar mass similar, because as the molar mass of a compound increases, the London forces increase, and the boiling point will increase because of that. So here, these molecules are similar in molar mass. So here we have an alkane, it boils at 36 degrees. Here's the ether, boils at 35. The alcohol boils at a much higher temperature, 117. Do you know the reason for that? What sort of intermolecular force do alcohols have that alkanes do not have? Hydrogen bonding. Okay, so this OH, remember ET phone home, we've got an OH bond here. This is a polar bond, and so this oxygen is negative, partially negative, the hydrogen is partially positive, and we can get an interaction between the oxygen of one and the hydrogen of another molecule. That's the strongest intermolecular force. Stronger intermolecular forces mean higher boiling points and higher melting points. The ether has an oxygen in it, and so it is a little bit more polar than an alkane, but there's no hydrogen bonding because this oxygen is only bonded to carbons, and so it cannot do any hydrogen bonding. So in terms of boiling point, the ether is going to be very similar to the alkanes. And here's an illustration of the interactions between an ether and water. Ethers, that oxygen didn't affect the boiling point very much, but it is going to affect the solubility, because this oxygen can interact with the water molecules. It can hydrogen bond with water molecules, but not with itself. It cannot hydrogen bond with other ether molecules, but it can with water, because we've got this oxygen here with the lone pairs. So this oxygen interacts with the hydrogens on water molecules, and so the ethers are going to be more soluble in water than the alkanes are, even though their boiling points are similar.